This is an automatic door controller in which 4 different users can automatically control the opening and closing of the door. So as you can see, there are 4 users, A, B, C, D, and we have designed the kit in such a way that this is the keypad and this is the A, B, C, D user buttons. So this is A, B, C, and D, and these are all the numbers. So if you press A, it will ask for a password. So the password is 0000, 4 times 0. So it will ask you a new password or the open gate option. So if you select B, the gate will be opened for some time and automatically closed depending on the timing. And in case you need to change the password, you can select A and enter the new password. So you can select A again and select new password. So now if you select A and select B, so as you can see, this is how the kit works. So you can order this kit from our site KitsGuru.com, where you will get 2 versions of the kit. One is where you will get this complete ready-made kit, and the other one is where you will get a complete knockdown kit. And with the help of our video tutorials, you will be able to complete the kit by yourself. Now we'll see what all components are used in this kit and how to assemble those components on the PCB, how to check the power supplies, and then how does this kit work. So first we'll understand how this kit works. So here we have 3 PCBs. As you can see, this is the PCB of the main microcontroller. This is the keypad section which will provide all the input, and this is the motor driver PCB which opens the gate, which controls the motor. So yeah, this is a section of the power supply. We have given a power through an adapter, and this is the on-off switch which controls the power to the entire unit. A bridge rectifier is used in case you are giving a power input through a transformer, and a capacitor is used to remove all the repulses which were produced during the rectification process. A parallel power supply is given to the motor driver IC circuit. As you can see, this is a parallel power supply here, and a voltage regulator IC is used because most of the components on this kit works on 5 volts. So as soon as you have anything which is input, which is done, which is any key which is pressed as an input here, the data is transmitted through these pins. As you can see, there are a number of pins here. The data is transmitted to the microcontroller. The microcontroller receives it and then decides, analyzes, and then takes the action accordingly. So first of all, it displays the output on the LCD screen here, and if the password is correct and if the motor has to be run or if the gate has to be opened, then a signal is sent here to this particular pins, and which then provides power to run the motor to this motor driver IC. So this is how the kit works. Now we'll understand how to assemble the kit components on the kit. So first we'll see the main microcontroller PCB. So this is a blank PCB. This is the top layer and this is the bottom layer. The top layer is where all the components are inserted. The bottom layer is where all the soldering is done. The technology that we use is called a through-hole technology, in which we drill holes from the top throughout the PCB and then solder the components on the bottom. So for reference, I'll keep this PCB in line with the ready-made kit so that we can understand the alignment of each and every component. First, we'll start off with the power jack, and then an on-off switch. On-off switch does not have any polarity. And then a bridge rectifier is used. This has 4 terminals. So while inserting, we have to ensure that the positive terminal, that is the longest stem, is inserted on the top left side. And then this is a 1000 microfarad capacitor, electrolytic capacitor. So the stem which is longer in length is a positive terminal, which has to be inserted in line with the positive terminal of the bridge rectifier. And then a 2-pin connector is used in order to give a parallel power supply to the motor driver circuit. And then a voltage regulator IC is used. So this is the first pin on the left side. Then the center one is a common, and then the third pin on the right is the 5-volt output. And then an LED is used. So an LED has polarity, so the stem which is longer in length is a positive terminal in case both the stems are of equal length. You'll notice that the LED is usually round in shape, but at the negative end it gets flat. So the LED will be inserted in such a way that the positive terminal is towards us. And a resistor of 1K with color code brown, black and red is used in order to protect the LED. So this completes the section of the power supply. Then we'll insert the IC. So this is the 28 pin IC base, and this is the IC. So as you can see, there's a notch on the top side. So the pin which is on the top left side of the notch is the pin number 1, and then counting counterclockwise, pin number 28 is on the top right side. So while inserting the IC, first we insert the base. As you can see, the notch is on the left side here. So first we'll insert this base. This is to protect the IC in case during soldering process, or in case the IC has to be replaced in the future, you can do that. So the first IC base will be inserted. On top of that, the IC will be placed, and this runs on a clock frequency. So we insert a crystal oscillator of 16 megahertz, and 2 capacitors of 33 picofarad in parallel is used to start the oscillation process. Then a micro switch is used here, which to reset the microcontroller, and a resistor of 10K with color code brown, black and orange is used here. This is to pull up the micro switch. Then there is a capacitor of 0.1 microfarad, which is present here and here, as you can see. So that has to be inserted. And then the male birth strips has to be used as a base. As you can see, there are total 10 terminals which has to be connected to the other PCBs. So for that, you need to connect the male birth strip, and then you need to connect the connector over that. And another LED is used, which is used as a signal indicator LED. So while inserting this LED, we have to ensure that the negative end is on the left side. And another resistor of 1K. You'll also see a bunch of metallic wires. So these are called jumper wires. When the connection is not possible from the bottom side, we use these wires and to connect to make the connections from the top side. And then a potentiometer is used. And then while inserting the LCD screen, first we have to insert a birth strip. So this is a male birth strip which has to be inserted first, and then the female part is to be mounted onto the LCD screen here, and then soldered, and then mounted onto the male part. So this completes the main PCB. So then we'll come to the motor driver IC kit. So first we'll insert the voltage regulator IC. The front face will be towards us. Then two 2-pin connectors, one for the power supply and one for the input from the microcontroller. And this is a symmetrical IC, so you can insert the IC base in any side, and the IC has to be present on top of it. So L293D, you can connect or you can control 2 motors simultaneously, but here we have connected only 1 motor. That is why we are taking signal from only 1 motor here. And you'll also see a jumper wire which has to be connected later on. So this is the connector for the motor. So that has to be, so the motor is connected, or this motor is connected to this particular connector. And then this is the main keypad. This is the keypad PCB. So first you have to insert all the pins here, the wires, and then you have to insert all the micro switches along with the jumper wires. And while inserting the buzzer, we have to ensure that the positive end, that is the end which has whose stem is longer in length, is present on the left side. So this completes this connection. So now we'll check the power supplies. For that, we'll use this digital multimeter. So first, the black terminal has to be connected to the body of the voltage regulator. The first pin should show the input power supply. The third pin should show the output. The first pin here should show the first pin on the microcontroller should show the 5 volts output supply, input supply. Then second and the second last pin should show 5 volts. And Then while giving a parallel power connection, first we have to see which one is positive. As you can see, the pin on the right is positive. That has to be connected to the pin on the left here. So this one is ground. And then while connecting these pins, we have to first see the connection. So as you can see, it is from the right to left, it is from bottom to right. The pin on the right here is connected to the bottommost pin here. So this is how the power supplies are checked. So once you've checked the power supplies, you can connect your ICs and the LCD screen. So this is how the connection is done, and this is how you complete the kit. You can order this kit from our site KitsGuru.com, where you'll get two versions of the kit. One is where you'll get the complete ready-made kit, and the other one is where you'll get a self-assembly kit, and with the help of our video tutorials you'll be able to complete the kit by yourself.